Okay, good evening. Tomorrow I'll be talking about area of a triangle. We can use our traditional method, base times height divided by 2. Okay, the big thing is just going to be solving for the height. And here's my notes. Okay, so the big thing, this is you're going to just draw a line down. First of all, height of a triangle is from a vertex perpendicular to this opposite base, okay? And that works out perfect for us because we form right triangles. And in right triangles, we can use SOHCAHTOA. But really what we're going to care about is just sine. Because we're going to orient our triangles. I don't care if your triangle's a scaling obtuse like so. You can orient it. You can move it around where it's just like so. Here's your origin. Here's your right triangle. And you're going to have, you'll know an angle. And this is just going to be opposite over hypotenuse every time. It's going to be, okay? So whatever triangle you have, whatever way it's oriented, just move it around so you've got it like so. And consider this kind of like your origin. And here is your radius, and this is your y. Okay? So I've oriented my triangle around. And let's say I know 12, and this is 14, and this angle is 42. Okay? I've got side angle side. I can do log cosine, solve for this side. But for area, all I need is this perpendicular distance. I just created a right triangle. Guess what? I'm solving for this height here, which is my y, or whatever you want to call it. Okay? So again, sine of my angle, 42, equals opposite over hypotenuse, which is y over 12. Okay? So y equals r sine theta. Remember, I've said that a million times. Okay? So 12 times sine 42. That's my height. My base will be this 14 divided by 2. That's the traditional way. And you might have to do law of sines, cosine, to solve for maybe an angle, solve for this side. Okay? But the big thing is, we're going to just make a right triangle and use SOHCAHTOA. Okay? We'll need to know a theta or this theta. And this would be the hypotenuse, or this will be the hypotenuse. Here's a hypotenuse, hypotenuse. And we'll be solving for opposite. Okay? Opposite over hypotenuse. Okay? All right. Here's something else. Last thing. This is another way. This is called Heron's formula. Okay? It's got the term S in here. S is your super perimeter. We're going to take all the sides of a triangle, A plus B plus C, and then divide it by 2, and that's S. And then now, this is pretty neat. The area of a triangle, let's say you've got a 4, 6, 8 triangle. My super perimeter would be 4 plus 6 plus 8. That's going to be 10 and 18 divided by 2 is 9. So S would be 9, and then we just plug it in here. Guess what? It's S times S minus A times S minus B times S minus C, and that's all under the square root. So for this, let's say we said our super perimeter was 4 plus 6 plus 8, that's 18 divided by 2. So that's going to be, I'll do this in red. Okay, that'll be 18 over 2 is 9. That's my super perimeter times 9 minus, let's say that's A. 9 minus 4 times 9 minus 6 times 9 minus 8. Okay, so 9 times 5 times 3 times 1, and square root it. That's your area of a triangle. That's it. Okay, so write down super perimeter, Heron's formula. Remember our basic formula, base times height divided by 2. We're going to draw a perpendicular line for the height of a triangle. We've got two right triangles. We use SOHCAHTOA to solve for. We need the hypotenuse and an angle. Okay, and we can solve for the height. That's it. We'll do area of triangles tomorrow. We'll continue what we've learned. We'll try to integrate law of sines and cosines. All right? That's it. Thanks, guys.